Look up at the night sky, and you are looking at a math problem that refuses to balance. There are hundreds of billions of stars in our galaxy alone. Most of them have planets. Trillions of worlds, bathed in the warmth of their suns, floating in the dark. Based on our models of how planets form and the sheer volume of habitable real estate out there, the universe appears perfectly built for life. And yet, when we point our most sensitive instruments at the deep quiet of space, we have found no confirmed evidence that anyone else is out there. No radio signals, no massive structures blocking the light of distant suns, no echoes of industry. This is the Fermi paradox. And investigating this silence forces us to confront exactly what it takes to survive in this universe. To understand the sheer weight of this silence, you have to look at the mechanical timeline of the cosmos. Our sun is just a normal, relatively young star. Our entire solar system is a late arrival to the universe. There are star systems out there that are billions of years older than ours. If a rocky planet formed around one of those ancient suns and life started there, they could have had a head start of 1 billion years on human beings. 1 billion years of evolution, trial, error, and invention. Think about the velocity of our own progress. 1,000 years ago, we were reading by candlelight. 100 years ago, we were just figuring out how to build airplanes out of canvas and wood. Today, we are splitting atoms, manipulating genetics, and flying helicopters on Mars. We did all of that in a cosmic fraction of a second. If another civilization had a billion-year head start, and if they expanded the way life on Earth expands, our models suggest we should see the physical footprint of their existence. We might expect to see artificial megastructures capturing the energy of their suns, or the chemical exhaust of their industries in the atmospheres of distant planets. But we see nothing. What is stopping life from spreading? To explain this empty sky, scientists propose a conceptual framework. They call it the Great Filter. The Great Filter is not a physical wall. It is a statistical bottleneck. It represents a step in the evolutionary timeline so impossibly difficult, so incredibly unlikely, that almost nothing ever gets past it. It is a biological or technological hurdle that weeds out life before it can establish a presence across the stars. The critical question is, where is this bottleneck located? It is highly possible the filter is entirely in our past. It might be the very spark of life itself. We still do not fully understand the exact physical mechanism that caused dead chemicals on early Earth to suddenly organize, build a cell wall, and wake up as a living thing. That jump from raw chemistry to active biology might be an extreme thermodynamic anomaly. It might require a sequence of events so perfectly balanced and highly improbable that we are one of the only planets in the entire galaxy that actually crossed the starting line. If that is true, the universe is quiet simply because it has always been empty. But what if starting life is actually the easy part? What if the oceans of distant worlds are teeming with simple, single-celled organisms? The Great Filter might be hidden deeper in the biological journey. For roughly 2 billion years on Earth, life was completely stuck. It was nothing but simple cells floating in the mud. They simply did not have the physical energy required to build complex bodies. Then, by what appears to be pure biological chance, one cell swallowed another without digesting it. They formed a partnership. One became the internal power plant for the other. That one extraordinary merger unlocked the energy required for all complex life on this planet. Forests, whales, and us. And even if a planet manages to produce complex animals, building a radio telescope is never guaranteed. Dinosaurs ruled the Earth for over 150 million years. They had plenty of time to invent a rocket ship, but they didn't. Evolution doesn't care about space travel. It only cares about survival. A highly advanced brain is an immense biological gamble. It burns massive amounts of calories, takes years to develop, and makes a species highly vulnerable in its youth. We traded heavy armor, running speed, and sharp claws for the ability to ask questions and manipulate tools. High-level intelligence might simply be an exceptionally rare evolutionary outcome. Now, you might think, maybe intelligent civilizations are out there, but space is just too big to travel across. They are simply too far away to hear. But that ignores the unforgiving mechanics of deep time. Space is undeniably vast, but the galaxy is ancient. Mathematical models suggest that even traveling at a fraction of the speed of light, using robotic probes that land on a planet, build copies of themselves and launch again, a civilization could theoretically map the entire Milky Way in just a few million years. A few million years is a blink of an eye on a cosmic timescale. The real barrier might simply be the time window. We look up and assume we are sharing the universe with others right now. But we might be looking at a delayed, disjointed timeline. Thousands of advanced civilizations could have risen, peaked, and quietly faded away millions of years before humans even discovered fire. The universe might be full of life, just never at the exact same moment. Which brings us to the most unsettling possibility of all. What if the Great Filter is not in our past? What if getting to our current level of technology is actually quite common across the universe, but the bottleneck is waiting right in front of us? This hypothesis suggests there might be a critical vulnerability built into the nature of technological progress itself. The same forces required to build a planetary civilization, the ability to split the atom, engineer biology, and harness vast amounts of energy, are the same forces that can sterilize a world. Unlocking these extreme energy sources creates a window of absolute peril. It takes an extraordinary amount of planetary resources to reach escape velocity and colonize other worlds. It is entirely possible that most civilizations exhaust their environments or trigger irreversible chain reactions before they can establish a permanent, multi-planet foothold. In this scenario, the silence of space is not empty space. It is the natural consequence of species that acquire the power of gods before they acquire the wisdom to wield it. The Fermi paradox does not offer us a neat, comforting answer. The absence of confirmed alien life is a blank canvas, and what we paint on it reveals exactly where we stand in the cosmos. If the Great Filter is still ahead of us, then the hardest tests of survival are yet to come. Our current struggles are just the prologue, and we will have to navigate a technological bottleneck that may have quietly dismantled countless worlds before us. But if the Great Filter is behind us, and we somehow navigated the extraordinary biological hurdles of the ancient past, the universe is not telling us we are doomed, nor is it promising we are special. It is simply silent. And in that deep, unbroken silence, we are left entirely to ourselves, forced to decide right now exactly what the future of life in this universe is going to be. But if the Great Filter isn't a technological bottleneck, but the planets themselves, exactly what kind of nightmares are hiding on those billions of so-called habitable worlds? Subscribe to join us as we explore the brutal reality of Earth-like planets in the next video. And check out our shorts for daily, bite-sized deep dives into the cosmos's most curious questions.